We will now move on to our fourth and final Convergence session of the day, and I will hand the baton to my colleague Seth to kick it off. Seth?
Thank you, Fadl. We're really excited for this Convergence session 4, from protection to sustainable utilization. Again, as with the previous sessions, please ask your questions on Slido early as you think of them, and so folks can see them come in and upvote them so that we're ready for the panel discussion at the end of all of the talks. All right, fantastic. Our first speaker will be David Kline, who is a staff scientist at the Smithsonian Tropical Institute in Panama. Let's play David's video.
Good afternoon. My name is David Kline from the Smithsonian Tropical Research Institute in Panama. And today I'm going to talk to you about our program that we call a Moonshot for coral reefs. And as you all are probably aware, coral reefs are a beautiful, dynamic ecosystem. They're considered the rainforest of the ocean. There's over 500 million people around the world dependent on coral reefs for their livelihoods. But unfortunately, coral reefs are being lost at an alarming rate due to climate change and local stressors such as overfishing and pollution. The way we've been studying coral reefs for the last 50 years or so is to swim along the reef and note down the different species of corals and their condition. And this has been sped up in recent times with different imaging technologies such as digital cameras, where we can now collect thousands of images in a single field season. But I would argue to do something meaningful for coral reefs, we need to speed up and scale up the rate that we can collect and interpret this information. We also need to automate it so that we can collect this data globally in a new and rapid rate. In order to work on this massive challenge, we've put together a team of collaborators across the Smithsonian, but we felt that radical collaboration was really necessary to take on this big challenge. And so we brought in some of the best engineers, scientists, and conservationists from all around the world to really take this problem on head on. So part of our research program is to use satellite and drone remote sensing, develop maps of where the coral reefs are, use new imaging technologies such as multispectral cameras and fluid lensing technologies to be able to understand the health of the corals at global scales more rapidly, and put a bunch of these technologies on underwater robots. We're also working with Conservify to develop sensor arrays that can be used to monitor the key environmental conditions on reefs, including temperature, pH, oxygen, nutrients, and light. And we're monitoring these conditions on the bottom next to the corals, but we're also putting these sensor arrays on our underwater robots to get maps of the environmental conditions and to understand how they're changing across the reef ecosystems. We're also partnering with the Conservation X Labs to use their DNA barcode scanner on our underwater robots to rapidly detect things such as coral disease outbreaks, outbreaks of coral predators, or invasive species, and get that information quickly enough so that we can intervene before it's too late. These underwater robots are being developed by a team at the University of Sydney and the University of Haifa, and they're working to make low-cost versions of these AUVs, and we're working to survey the reefs not only from the shallow reefs, but all the way down to the mesophotic reefs in collaboration with the Cal Academy of Sciences. But these robots can collect millions of images in the matter of weeks. In order to get data from imagery at a scale that will be useful for conservation, we developed a website called CoralNet that can analyze coral reef images 10,000 times faster than a coral ecologist and about 90% accuracy, using facial recognition technology similar to what's used by Facebook to be able to identify the different species of coral and reef invertebrates from reef imagery. We're also collaborating with a couple teams from Israel who are developing new 3D printing technologies that can print in ceramics as well as in calcium carbonate, or the material that a coral skeleton is made out of. And they're printing 3D reef structures as well as artificial corals. And we're working with them to use our system to identify the most optimal locations for reef restoration efforts, and to evaluate the efficacy of these different restoration technologies. We're also collaborating with a couple of conservation groups, including the Wade Institute and the Healthy Reef Initiative, so that we can rapidly translate our data into information that's useful for coastal communities, so that the coastal communities can ensure they have healthy reefs long into the future. And with that, I want to thank you for your attention and thank our funders. Thanks so much.
Thank you so much, David, for that really exciting video. I also want to mention that we have 227 members on Slack already. So if you haven't checked out our Slack channel, please, I invite you to move over there to continue some of these discussions that we're starting here with these very exciting talks.